Before we begin using the gameplay debugger, we should disable the AI's movement. This will make it easier for us to focus on the perception system. We can do this by disabling the event we created within the AI third-person character earlier. Select the AI third-person character from the content browser and double-click to open the blueprint editor. Locate the begin play event, and while holding down Alt on the keyboard, left-click on the execution pin. This will disconnect the begin play event from the set timer by event function and mean that our random wander event will never be called. Press F7 or hit the compile button in the toolbar to recompile the blueprint and ensure there are no errors. Once that's done, we can save the blueprint and close the blueprint editor window. We're nearly ready to look at the perception within the gameplay debugger. There's just one more change I suggest we make. Before we start the game, we may want to disable temporal anti-aliasing. Because of the way that TAA works by blending several frames together, single pixel lines, such as the debug we're about to look at, can be very hard to see. Navigate to Project Settings, Rendering, and Default Settings, and then locate Anti-Aliasing Method. From the drop-down, change the setting from Temporal AA to None. Then we can close the Project Settings window. Now we're finally ready to look at the perception category within the gameplay debugger. Let's start by running the game by either pressing Alt-P on the keyboard or pressing play from the toolbar. Walk towards and face our AI character, and note that they're no longer running around the level, which is just what we want. Next, press whichever key on the keyboard you have bound to activate the gameplay debugger. Now, as we're focused on perception this time, disable the AI and behavior tree categories by pressing 1 and 2 on the numpad. Enable the perception category by pressing 4 on the numpad. Note the sphere that is being drawn around the player. This represents the fact they are currently being perceived by the sight system. Note that sight is set to 1, indicating full visibility, and the age is set to 0, indicating this is current information. Age refers to the age of this perception data, in other words, how up to date it is. As the player is currently being seen, the information is current and fresh. Now let's move the player outside of the AI's vision. Note that the age value begins to increase, and this area now represents the last place that the player was perceived by the AI sight system. Now let's move back into the line of sight of the AI character. Note that the previous position is immediately discarded and updated with the current information. Now let's press Tab to activate the spectator camera and reposition ourselves above the map for a better view. Note that we can now see the edges of the inner and outer ranges represented by the green and pink areas respectively. We can also see that at the moment they extend way beyond our test area. Let's fix that by adjusting these values in the sight sense to be a bit more representative for our play space. Let's return to the AI character's sense config and dramatically reduce both the in and out ranges so we can demonstrate how they work within the game. Select the AI underscore third person character in the content browser and double click to open the blueprint editor. With that done, move to the components panel in the top left hand corner and select the AI perception component. Then move over to the details panel and the AI perception rollout. Ensure that the senses config, the first element, and the senses rollout are all expanded. Next, adjust the sight radius from 3000 to 1000. Then adjust the loose sight radius from 3500 to 1500. Compile the blueprint and save before closing the blueprint. Next, reposition the AI within the level so that there's lots of space in front of them so that we can test it out in game. Now we are ready to see what difference this makes within the game. Begin gameplay by pressing Alt-P on the keyboard or pressing play in the toolbar. Once again, move over to the repositioned AI character and activate the gameplay debugger as before. Disable the AI and behavior tree categories and enable the perception category. Press Tab to activate the spectator camera and move above the level to get a better look. Now we can see that both the in and out range are much more reasonable, and we've actually got a chance of escaping the AI within the level. Press Tab to return to the player character. Ensure that our starting point is within the green circle. As we walk away from the player character, we won't be hidden by the pillars. Note that we can move beyond the green circle and still have our position updated. Note that it only stops updating when we then move beyond the pink circle. Note that as we move from beyond the pink circle to within it, our position doesn't update any longer. This is because the player is only considered visible in this area if they entered it from the green inner range first. Note that this update can also be broken by the AI losing line of sight with the player, for example, using one of the pillars we created. Now, just like moving beyond the pink circle, this will no longer be updated until we return to within the green circle. Doing things in this manner makes the transitions between visible and invisible feel much more natural, as a player's visibility won't constantly flip-flop as they cross over this one boundary. However, in some cases, this setup may not be desirable, and in that case, you could just set the inner and outer ranges to be the same value. In this video, we used the perception category of the gameplay debugger to gain a deeper understanding of how the sight sense works. We disabled temporal anti-aliasing so that our thin debug lines were easier to see, before using this debug to visualize the sight perception ranges of our AI character. We saw how the inner and outer ranges work together to provide a natural transition between the player being visible and invisible. Finally, we reduced the sight ranges of our AI character so that it's actually possible to move beyond their maximum range within our small level.